All right, so we're going to go through the notes for section 1.7 on inequalities. And the idea here is we've got many different kinds of inequalities, again, pulled from different parts of Algebra 2. With the exception of maybe one or two styles here, there's most of it you'll have seen. We're going to add a little new stuff here, though, so it's going to be a little addition to your review, taking the inequality concept a little bit further. Ones you guys would recognize from Algebra 2 would be like number 1 and number 3 here, linear. Actually, that can go back a little further than Algebra 2, and absolute value. The quadratic inequality, I think you guys might have done a little bit of that as far as graphing and shading goes, but I don't know that you did it as a solving problem. And then the rational one, I would be fairly certain you guys did not do that in Algebra 2. So we'll just go through a little bit of each, remind you guys how the ones you know work, and then show you how the new stuff works. And that's going to kind of be it for the notes. When the notes are completed, we'll do a little quiz review video. And then you've got a partner quiz today on 1.6, and that'll be explained a little bit later on with another video. Okay, so let's go ahead and take a look at solving inequalities. So you've got the types here listed out. There's linear, quadratic means, you got x squared. It could be higher degree. What higher degree means is probably something that's factorable but has like an x to the third in it. And then absolute value and rational, which is in the form of a fraction. And solutions here are going to be written as intervals. So when we get done, we're going to want to use interval notation. And just remember how the inequality symbols match up. The idea is, that parentheses without the equal to are an open circle, and brackets with the equal to are a closed circle. Okay, well, let's start heading through some examples here and show you guys what we're looking at. So we're going to start out with linear. And I think the idea of linear is probably some of the easiest stuff you're going to do. It's just kind of some basic solving, but there are some things to remember. And what we mean by linear, again, is that we've got exponent 1, highest exponent 1. You might be asked to graph on a number line, and for the linear ones anyway, I may not do all of that with you guys. I think you'll get the idea of when we first did this earlier in the review chapter. But the solving some pretty basic stuff. So we're going to start out with distribute the sign in over here on this side. So -1, -8x. Then it's get x on one side, number on the other, your typical kind of algebra solving type stuff. So I'm going to add the 8x over, so this is going to be 5x. And subtract the 4 over -5. Divide by 5, x is less than or equal to -1. Pretty straightforward, inequality kind of idea. Then as far as the number line concept goes, if I'm putting this on a number line, I'm going to do, 0 is a good idea actually. Then for a little bit of reference, there's -1. It's a closed circle. And less than shade. Now as an interval, remember interval notation, when you get done with your answer, you want to go ahead and write it as an interval. So we're going to say all the values that are less than or equal to -1 would really say coming in from this side, right? That's negative infinity to -1 in bracket. So remember the bracket is the included idea or the equal to idea. That's pretty much it for that one. Look at the next one. The idea is an in-between concept. And so with the in-between, you could expect that you're going to have, your idea of your interval looking as between this number and this number when you're done. The solving kind of works in a typical way. You want to basically do all your work like in every area. So whenever you do an operation, whatever it is, do it in all 3 spots. So for example, when we say, let's get 2x alone, and you're going to add 3, you got to add 3 everywhere. So add 3 over here, add 3 over here. Then divide by 2 everywhere. So divide by 2 in the middle, divide by 2, divide by 2. So between 4 and 11. Open circle, closed circle, shade in between. Translating the inequality to an interval, which again is always the way we're going to write it, we'd have parenthesis 4, 11, bracket. So I think those two are, again, pretty simple inequality solving ideas. It's almost algebra 1 really type solving, but make sure you write your answer as an interval. All right. So next thing to look at are, the absolute value problems. And with absolute value problems, the basic difference here is there's really like a setup kind of that you've got to look at based on the symbol. Is it the absolute value of something greater than or less than the number? And you guys may remember this, and there's a little chart up here from your book on page 81. But when it's the less than, we call that the in-between setup, which really means the solutions are going to sit between 2 numbers. When it's the greater than, we call that the OR setup. And in terms of visual, that's the idea of it going off in opposite directions if you're shading on a number line. Really, you just got to get in your head which setup is which. So, absolute value of anything less than a number, you're going to go in between. And absolute value of anything greater than or equal to, those work to a number, that's going to be an OR. So really, let's go through the OR first. And how I know that this example number 3 is an OR is that I see the symbol is greater than or equal to. And we're talking about being this category right here. The way the ORs work is pretty simple, actually. You can just start out by pretty much copying down the original problem. So I'll go 2x minus 3 greater than or equal to 7. Where the OR comes in is there's another one that basically says the same thing, but what you do is you change the direction of the symbol and you change the sign on the number. So I always just say for ORs, change the symbol, change the sign. And you solve those two individually, which is, again, some pretty basic algebra. And in terms of what I'm expecting to happen, ORs will go off in opposite directions for shading, so that's what you see in the chart up above, and that's what I should get. Again, the solving part of this, shouldn't take you guys very long. So there's that one, then over here. Okay, so a little bit of quick solving there. Then again, the idea of putting this stuff on a number line, and then also answer in interval notation. I think I'll probably skip the number line part of this. I think you guys got that figured out. But with having the two separate intervals, values that are less than or equal to -2, that's going to start you out at -infinity coming up to -2 bracket. And then those values that are greater than, so we'll say union, greater than or equal to 5, so that's 5 to infinity. So there's your interval translation from your inequalities. So again, it's a setup idea. Now, it turns out that the ORs can actually be done as an in-between. And the in-betweens can be done as ORs, right? But I don't do them like interchangeably because I think you actually mess yourself up when you start doing them two different ways. Plus, I like the visual matchup. Like when I do an OR and I've got two separate statements, I think opposite directions on a number line, and I also think two separate statements for my intervals. So it like matches with what I'm doing. And when I do the in-between setup, I do that for a reason too, because on a number line, you're going to shade in between. On an interval, it's going to be listed as one interval where you go from number to number, and things just match up better. So I think if you stick with a certain setup and don't kind of mix them together or use one on the other, you're probably going to be better off and less mistakes. Okay, well, let me show you the other variety then. So we've got the greater than and or. Let's do the less than and in between. Now, I know you see a greater than here when you look at this problem, but the thing is, there's a little twist about inequalities that we have to remember. And also going back to the review chapter when we were doing regular solving with equations, you've got to isolate the absolute value, so get it by itself. And that's a pretty simple thing to do, subtract 4, then divide by -6. So if you subtract 4, you've got -30, divide by -6. Now here's the thing you got to catch. When you divide by a negative, do you guys know what it does? Changes the direction of the inequality symbol. So division by a negative or multiplying by a negative both do that. So when I say I'm dividing by -6, I'm going to change the direction of the symbol to this. So again, remember I've got -30 over here if I subtract 4. Divide by -6, I'm going to get 5. But division by a negative changes the direction of the symbol. Now that makes it a less than, and a less than is an in-between style problem. And the idea with in-betweens is you actually are going to, pretty much, again, like the other one, copy down the original problem. But you do the symbol and the sign change over here. And that puts x between two numbers, which is what's supposed to happen. And again, the reason I like to stick to the certain setup is that it matches visually with what I would put on a number line, and it matches the way I would write the interval. And so having everything match, I think, is a good idea. Again, the solving for this style is to make sure that you do whatever you do as an operation, you do it in every spot. So if I subtract 1, I subtract 1 here, and I subtract 1 here. And then divide by 3, and again, I divide by 3 in every spot. And so there's my final inequality. And again, I think I'll probably skip the number line just to save a little bit of time. I think you guys are pretty good with that. But translate it to an interval. So parentheses -2 to 4/3, parenthesis. So there's the two setups. There's either a greater than, which is an OR, two separate statements, shaded in opposite directions, and two separate intervals. Or there's an in-between, one statement or one setup, and then shade it between if I was doing a number line, or an interval that actually reads as one interval, number to number. So again, just getting those setups down is really the key. Once you have that, these two problems are pretty much basic algebra again. So those to me are the ones that I would flash back from Algebra 1, Algebra 2. You know, now we're going to go to quadratic, something that's not quadratic but it's factorable, and then the rational. And to me, those, you may or may not have seen that in Algebra 2. I think you're probably not going to recognize much here, but we're going to try to sort of think of things in the same way, and I'll give you some visuals to help you out too. All right, let's try to get through one more problem here before I run out of time on this video. So there's a set of steps here. These are in your book on page 79, so you don't have to sit here and copy them down. Just take down page 79 for the quadratic and higher order functions. And the first thing you got to do is get everything on one side, 0 on the other. So this step is very similar to solving an equation. You know, if you're going to do it by factoring, which is what we're trying to do here, everything on one side, 0 on the other. So I get everything on one side, which it already is in this case, and I'm going to go ahead and start factoring. So factors of 6 that are going to give you 5 are going to be negative, positive in the middle. We're going to have to go positive 6, negative 1. Now, in terms of solutions, here's the thing that's different. What you don't do is you don't individually, and this is what students do, so here's a no-no, right? Students will say, well, if it's like solving an equation, then I guess I'm going to do it like I would do an equation. I'm going to individually set up the inequalities and solve. And then I'm going to say, actually, no. Because the thing is that what you're actually figuring out here is not the individual effect of each factor, but how they work together. So it isn't the x plus 6 greater than 0 and the x minus 1 greater than 0. It's the 2 multiplied together greater than 0. So it can't really be done this way because you're not accounting for the combined effect of the two factors. Now, the way you do it correctly is you say, okay, what I'm going to do is just think of this as, you know, what would be my zeros? And zeros are actually what you get by solving. So if I was solving this, I would get negative 6 and I would get 1. I'm going to put those things over here on a number line. Now, I don't have to be real specific. This is like my test number line. I'll explain what I mean by test in a second. But I put them over there on the number line, and I use that to sort of represent intervals of possible solutions. So you've got things that are going to be less than negative 6, so this area in here. You've got solutions that are between the two, and solutions that are greater than 1. Now, of those three areas, some of them represent solutions to the problem. And what I'm actually concerned about is which values would produce a true statement. Now, a true statement for us is what this is telling us. And greater than 0 means positive solutions. So any values of x that I choose plugged into the inequality right in here, if they produce positive, they're true, and then that area is part of my solution set. So it's your job to pick. Now, you can pick anywhere you want. I'm going to start from left to right. And let's say I take just any number out in this area would be fine. I'm just going to go with negative 7. And what I do with negative 7, I do this in my head, is I go back over here, and I plug in negative 7, and I see what is it producing for signs. I'm not even really concerned about the actual numbers. I'm just concerned about the sign. So if you do negative 7 plus 6, that's negative 1. So it's negative. Negative 6 minus 1, negative 8, that's also negative. And then negative times negative is positive. So the values, the numbers in that area produce a positive result, which means actually true. They satisfy the inequality. If you go into the middle area and pick anything you want, and I guess if I'm in the middle area, I'm probably going to go with 0 because that's kind of simple, right? Put in 0 into the original inequality right in here. Well, if you put in 0, 0 plus 6 is 0, that's positive. 0 minus 1 is negative. Well, positive times negative is negative. Okay, that would be false. That would not satisfy the inequality. And then check something in the last spot. So take, like, for example, anything out here. Let's say I go with 2. Well, now I'm going back to this again right in here, and I'm saying let's do 2 plus 6. That's positive. 2 minus 1, that's positive, and positive times positive is positive. Check. So when I get a true statement, those areas are then my solutions to the inequality. Now, as an interval, I would say, all right, then the solution area is negative infinity to negative 7, excuse me, to negative 6, 0. Oops, sorry about that. Touched something I shouldn't have there. So to negative 6, and then there's a jump. And then starting up again at 1 to infinity. So any numbers that fit into those ranges of those intervals will satisfy the inequality, or will give